Now that we've actually learned how to calculate the empirical formula, we can take it one step further and now begin to look at molecular formula. The definition for molecular formula is the actual number of atoms in a compound. That is the definition of molecular formula. So once you've determined the empirical formula, you can use the mass of your empirical formula and the mass of your molecular formula to determine what the actual formula is. Okay? So if we look at problem number 1, it says the empirical formula of a compound of phosphorus and oxygen was found to be P2O5. Experimentation shows that the molar mass of this compound is 283.89 grams per mole. What is the compound's molecular formula? So they're looking for the molecular formula. That's what my answer needs to be in. And they give us a few things. They give us the empirical formula, and they give us the molar mass of our molecular formula. So if we know that our empirical formula is P2O5, and we know that our molecular formula weighs 283.89 grams per mole, what we need to think about is we need to be able to compare empirical formula to molecular formula. Now, if you've ever made a puzzle, you know that a puzzle has several pieces in it, right? So if this is my puzzle, it has several pieces. Now, in a molecular formula, instead of having several different shapes of pieces, it would be as if a puzzle had exactly the same pieces. They all looked identical. Now, the puzzle would be boring, but it's a little more relative to our conversation. Imagine that molecular formula is the entire puzzle, and each piece is our empirical formula. Now, they've told us what our empirical formula looks like. It's P2O5. And they told us that my entire puzzle weighs 283.89. So in order to figure out how many of my empirical formulas make up my molecular formula or my puzzle, so how many pieces are in my puzzle, I need to be able to compare the mass of one piece to the total. So in order to do that, I need to calculate the molar mass of my empirical formula. So I'm going to calculate the molar mass of P2O5. Again, if you are having trouble with calculating molar mass, please refer to my molar mass video and watch that first. So I have two potassiums and two phosphorus atoms, not potassium, and 5 oxygen atoms. If I look at the periodic table, I see that phosphorus has a mass of 30.97 and oxygen has a mass of 16. So when I multiply them together, I say 2 times 30.97 will give me 61.94. And 5 times 16 will give me 80 grams. Now when I add them all together, I get 141.94 grams per mole. So now I know that my empirical formula, or one piece of my puzzle, weighs 141.94 grams. Now this is not equal to my molecular formula's mass. This tells me that I have to have more than one puzzle piece in my puzzle, or more than one of my empirical formulas. So to determine exactly how many I have, I'm going to take the molar mass of my compound, 283.89, grams per mole, and I'm going to divide it by my molar mass of my empirical formula. This will tell me exactly how many I have. And when I calculate this out, I will find that there are 2 empirical formulas in here. So that tells me I have 2 of my empirical formulas that make up my molecular formula. So the way I would write my molecular formula, now that I know this, is I will take the number 2 and I will multiply it by my empirical formula. And when I do this, I multiply the number 2, which we pulled from the number of empirical formulas in my molecular formula, and I'll multiply it by each subscript. So 2 times 2 will give me 4 phosphorus atoms, and 2 times 5 will give me 10 phosphorus atoms. And that will be my molecular formula. And you can see that it's related to my empirical formula, because if you reduced 4 and 10, you would get 2 and 5. You could also double check your answer by calculating the molar mass of P4O10 and realizing that it will give you 283.89 grams per mole. If you have any other questions about molecular formula, please ask me before or after class.